So in this video I'm testing the 17.5 Trinity Revtech motor. I do like the Revtech motors. They've been very good motors, the ones I've used. I've just been swapping rotors just to see what the kV and amp draw is. Now, that is not necessarily the most important thing. Gauss is very important, of course. That's the strength of the magnetic field of the rotor. Keep in mind that the stator, that is different, right? Think about it as a magnet, but it powers on, powers off. Versus the rotor is a permanent magnet. Now, there are a variety of things that can affect your kV. It can be, for example, the resistance of the stator. The resistance turns. The more turns, the more resistance. Therefore, it'll be slower. The less turns, the less resistance. Therefore, it will spin faster. So if you have the same rotor, but more turns, it's going to be slower. If you have less turns, it'll rotate faster. Those are some of the basics. Now, let's just say you have the same motor, such as this, 17.5. If the Gauss is the same, and you put a smaller diameter, it'll rev higher. If you go with a higher diameter, it'll have more torque, but it'll rev lower. Now, if you have the same diameter and you have more Gauss, it'll have more torque. And this is what I have here. So this is the 1152, and this one here is a 12.5 millimeter rotor, so it's the same diameter as the stock, but it's about 100 Gauss more. And the results are actually quite good, surprisingly good with this rotor. It's very interesting that this is an optional rotor, not the stock rotor. I guess it makes sense. Maybe not everybody wants the rotor, or it just allows for tuning. They can sell you another rotor. But KVs are really good. Now the RPMs, ignore the RPMs. Those are a product of volts and the KV. So KV is the constant. So that's your revolutions per volt constant. That's really what we're looking for, as well as the amp draw at a particular timing level or degree of timing. I've done tests. To watch my older videos where I test some of the others, but in the data table I am going to have information about this rotor and the other rotors. You're just going to have to pause that section. But one of the nice things about Trinity, especially if you're just getting the hobby and you're looking for motors that you can tune, is that they do offer a variety of different rotors, and you can swap them. It's very easy to swap them. They generally do come with brass shims, and you can reshim them. And it just makes it simple, especially because you only have to remove the end bell, and it's very easy to remove. 3 screws, and then it comes out, and then rotor pops out. You're going to need some pliers for that, though. It's a little tough if you don't, to be honest. But the rotor, depending on your application, that's the rotor you're going to be using. So I'm not really recommending one over the other. I'm just showing you the difference. Now this, that was 4.7 amps. That was very good. So 4.7, that's probably around the sweet spot. You can increase the timing just a little more to try to get something above. But if you look at this, if we go to about 55, it goes through the roof. This is the data table. These are some previous motors that I've tested, such as the Phantom Icon V2 Prospect. This is the one I'm running in my buggy currently. EcoPower Slingshot, very inexpensive. It's a good option if you're just bashing. Turnigi, another good option if you're just bashing. But if you watch the video where I talk about this, I do recommend the EcoPower over this one, just because of discount codes. They're essentially the same thing. Well, when it comes to performance. But here we go. So X Factor, this is the stock motor. So really we're going to be looking between these two right here. So this is about a 4 amp. This is a 5 amp. So we're looking about 3,000, 3,100 kV. It is a 12.5 millimeter rotor. This is the diameter. Gauss, we're looking at about 1700, plus or minus. Now, I did do a video where I compare it with the 1150. There are the specs, and here's the 1151. But this is really what I want to compare. So it's the 1152. It's the same diameter rotor, but it has 100 Gauss more. And the interesting thing, here we have, this is very close to that other one. I said it's about, right, it's just 0.1 difference. The other one I said it's close enough to a 4, but it's a 3.9. This is a 3.8. So if we look at the kV, it's very similar. It's very similar kV, 3050 versus 3003. Now, if we look at this one, 5 amps, 3092. This is about 49 degrees. This one's about 50 degrees, so very close. We're looking at 3139. Therefore, between these two rotors, this one is actually a very good choice. Same diameter, slightly stronger magnetic field. It is 1 additional degree on average, which will make a difference. A degree will make a difference. But interestingly enough, this one drew less amperage, which I'm trying to figure out. But this is the data that I extracted. Now, quick note, I generally test with the end bell starting at 30, 35, 40, 45, and then 50. So there is a large error initially, and then it evens out. And that's the case with most of these, to be honest. Well, with Trinity motors. But here you go. I hope this information was useful or at least entertaining. Thank you very much for watching. Please subscribe if you have not, and I'll catch you on the next one.
What? Oh, my hair! My tongue! My rod!